And another thing we wanted to do is make sure that it was compatible with distributed database protocols for sharing biodiversity data. And what that means is that you could use the data model to collect information about your plants and then be able to share those with biodiversity informatics efforts that are out there. And those things are basically portals like GBIF, who basically the Global Biodiversity Information Facility. They collect data from all sorts of collection providers, whether they be natural history collections or living collections like ours. And basically, scientists can go to their site and use their site to be able to assess the status of biodiversity in the world. We have a lot of rare and endangered plants in our gardens, and it's important information to have out there for scientists to be able to access. So basically, we wanted to make it easy for you to be able to contribute to those efforts if you wanted to. The design of the data model project it was very much like modeling an entire city. The complexity that we have in gardens, we have a lot of the same things that cities have. We have sewer systems, we have electrical systems, we have transportation systems, we have irrigation systems, all sorts of different things that we have in the garden. It's just on a slightly smaller scale than what a city has to deal with. So we did a community survey of the Botanic Garden and Zoo community at the beginning of the project, and had a really good response rate, and found out that, as we suspected, that plant records were obviously one of the most important things to have in the data model. The next most important was this idea of base map features, which are kind of background information to your to your maps that you create. So information on water and soils and topography and things like that. And the next thing that came up was facilities and infrastructure, so things like buildings and transportation systems and things like that. Those came up as being the most important. Based on the results of the survey, we essentially designed the base map and facilities infrastructure pieces first. Now, the base map we knew was the foundation to the data model, and you needed to have that information in there no matter what. And we had heard from a lot of people that who have been successfully using GIS that the facilities and infrastructure piece is the easiest way to provide a return on investment with GIS, because if a utility line breaks, say a gas line breaks, and you have the information easily accessible to find out where that valve is to shut that off, and you can shut that valve off in a number of minutes and save who knows what kind of disaster, then the GIS pays off really quick, and your administrative staff get that and see the value in it really quick. And then the third thing that we built on top of those two pieces was what we call a basic plant collections module, and this basically doesn't duplicate the capacity that a dedicated plant record system that a lot of people already have. It doesn't duplicate that functionality, but it is complementary to it and can work with it. So basically you can have just the information you need to produce your collection maps in your GIS, and you can link to information in, say, BGBase or a FileMaker database that you may have at your garden. So currently there are over 150 different objects in the model, and what that means is there's basically lots of pieces that we've modeled at this point. And this diagram to the right here, you can get a glimpse of the complexity of it, but you don't have to understand the whole thing at this point. So one of the things you're going to need to know a little bit about is what we call geodatabase terminology, and there's a certain language to speaking the data model that if once you learn some of these words, it'll make things a lot easier in the future. So a data model, you download it from our website or from Esri's website, and then you create a geodatabase, which is essentially just like it sounds. It's a geometric database. It's a GIS database. And inside of this geodatabase, there'll be a number of different things. And the foundation of the whole thing is really what we call the feature class. And this is an object that stores information on points or lines or polygons, or sometimes annotation, which could be labels for features on your map. And each one of these points or lines or polygons will have attribute information attached to it from the database, and those attributes can be whatever you define, but we've gone through and defined a lot of those for you so that you can just start plugging in information right away. Another object in the database is called a table, and that's just like a regular database table. So it's kind of like a feature class without geometry, so it's just a table that has rows and columns and different information in it. And then we have relationship classes that basically connect feature classes to other feature classes, or connect feature classes to tables, or connect table to tables. And there's not too much else to say about those, but they do come in a couple different flavors. You can have what's called a one-to-one relationship, where one feature matches up to exactly another feature in another feature class or table. There can be one-to-many, where one feature, like a point, can have many bits of information about it in other tables. And then there's a many-to-many, where that's very complicated, where many features have many different types of relationships, and we won't see that one very often. The next thing that's important in the geodatabase is a topology. And topology is a special thing set up for GIS databases that defines spatial relationships and create rules to govern them. So the example I like to use is that we've set up a rule in the data model for sidewalks and buildings, and we have a rule that says that a building can't be on top of a sidewalk. So essentially, if you've gone through and you've drawn in your sidewalks and you've drawn in your buildings, and the sidewalk's supposed to go right up to the door of the building, but you did a kind of a sloppy job drawing it, and there's a little bit of overlap on those two, the topology will show you that that there's an error there, and it will highlight that area in red and make it really easy for you to go through and fix relationships, or fix the geometry so that they follow all of the rules that we've defined. And basically add some quality control to your data. Another thing that's inside of the geodatabase is a feature data set, and feature data sets contain feature classes that have something in common. So if feature classes like buildings and sidewalks, if they have a topology rule defined, those two need to be in the same feature data set. That's about all you need to know about those. You can store rasters inside of the geodatabase, and rasters are basically images. Things like aerial photography or satellite imagery, you could store those inside of there. And the last thing that you need to know is a domain, and a domain is essentially a list of valid values that you can select from when you're entering data, and they kind of add some quality control to the data and allow you to only select values from a list, therefore not inputting bad data. This is an older version of what the data model used to look like, but I'd like to show it just to kind of convey the complexity of the data model. And basically what's going on here is the blue things are feature classes or tables, and then the green things are the relationships between them. And then there's little green lines that kind of go between everything to connect things together for relationship classes. So the idea here is that the data model is really complex, but you don't have to deal with it on this level. We've kind of done all this thought process in the background so that you can just start using things in ArcGIS or ArcMap and get going right away without having to think about these kind of relationships. But I do want to show you a little bit more about how they work. If we zoom into a portion of the diagram in the previous slide, we can look at how feature classes and tables are kind of connected. So this is what I like to call a geodatabase structure diagram, and it shows the kind of zoomed out view of how things work together. So in the upper left hand corner of this slide, you'll see that there's a polygon feature class for sections. In sections, we've defined as smaller administrative boundaries for a garden or thematic area, but essentially they are you can think of them as just parts of your garden. So we have some people call them collections. We have parts of our garden like our California natives section, and we have our East Asian plant section. So this would be a polygon boundary for that part of our garden. And the relationship we've defined here is that this section has structures, and that's the green object right under section. And basically that connects sections to structures, and it means that there could be several structures inside of this section. So and in the light blue under structure, you can see that structures could be of different types. They could be an administration building, they can be an education building, an exhibit, facilities building, research building, visitor amenity, mixed use, or other. And then we have some other relationships in here, such as a structure has enclosures. So in the case of a zoo, this building or structure may have an animal enclosure in it that could be of type for amphibians or birds or insects, plants, reptiles, mammals, or other. And structures also have another relationship with entrances and exits. So we've defined a relationship so you can map your entrances and exits to buildings or to your property or whatnot, and then relate these together so that when you click on the structure, it also brings up the information about the entrances or exits. And then additionally, we've set up another relationship between structure, and structure has point of contacts, and that means that you can have contact information associated with that building. So in the case of emergency, you can click on the building, you'll know where the entrances and exits are right away for routing people in or out, and you'll also know the contact information of people to get a hold of to maybe open the door or to turn the fire system off, something like that. So the relationships we design into this make a big difference when you're trying to use your GIS to manage your garden. If we zoom into structure a little bit more, we can look at the schema level for the geodatabase, and it actually shows you the different fields that are inside of the structure's feature class. So here we have fields for type, or for structure ID, which is a unique ID that we assign to each building. We have a field for type, which are those types that I mentioned, such as administrative, research, etc. The name of the building, address for the building, information about when it was constructed, how long it's supposed to last, a link to blueprints, how many levels does the building have, the presence or absence of things like water utilities, sanitary sewer, heating systems, cooling systems, fire suppression, you name it. Whether the building is ADA accessible, and then some fields that are kind of bounded in green below, which link to other feature classes in the data model. The upper right, we have the example of a coded value domain, which basically says that the only valid values for this domain are yes and no, and you can see that we have that domain assigned to the presence or absence of utilities and heating, cooling systems, things like that, so that when you want to fill in that data, you can't put maybe in that box, you can only put yes or no. And then in the lower right here, these green, there's a little bit of detail about relationship classes. Now that we've learned a little bit about the data model, I want to talk just a little bit more about the rest of this training series. So, as I mentioned at the beginning, is that we've organized this series into a number of different lessons, and each lesson will cover a different step in the process of creating a GIS for your garden. And now we're going to assume that you have basic knowledge of ArcGIS already. These lessons aren't meant to teach you about how to use ArcGIS. But they do build on some of the previous lessons that hopefully you've had some access to. And we're assuming that you have equivalent knowledge to at least the Esri course, which is offered both instructor-led and online. That's called Learning ArcGIS Desktop. So if you've completed that course and passed the test successfully, then you should have the knowledge required to be able to perform most of the tasks we're going to go through in these lessons. So we're using ArcGIS 10, the latest version of ArcGIS, to complete these videos. I try to provide comments for people using ArcGIS 9 as much as possible, but there have been some significant changes between the two versions. So if you can put ArcGIS 10 on your computer, you'll have much better results. And finally, data collection. When we go out into the field and do data collection, we're going to be using Trimble GPS hardware and software. And I try to make these videos as independent of the vendor products, but you're going to find that Trimble stuff is definitely being featured. And that's what we generally recommend for using when you're purchasing equipment. Okay, so that concludes Lesson 1. So today we learned a little bit about the resources that the Alliance for Public Gardens GIS has to offer, a little bit about the ArcGIS Public Gardens data model. In our next lesson, Lesson 2, we will learn how to download the data model and install it to a new geodatabase on your computer, and take a little bit of a tour of the features that it has to offer. All right, see you next time.